In this section, we will be looking at linear inequalities. We're going to start by talking about how to solve linear inequalities. Solving an inequality means finding the set of values that make the inequality true when evaluating with that value. To find this value, we must use algebra rules to isolate the variable on one side of the inequality. That should sound really familiar. It's almost exactly word for word the way we solve equations. But a very important difference between linear equations and linear inequalities is that when we multiply or divide both sides of an inequality by a negative number, we must flip the inequality sign. You will need to write the solution set using one or more of the following methods: as an inequality, as an interval, or as a graph. So we're going to practice all of these. Solve for x, write the solution set as an inequality, graph the solution set, and write the solution set as an interval. So first up, we have 2x minus 7 is greater than 1. I'm going to solve it just like I solve an equation. Add 7 to both sides. 2x is greater than 8. Divide both sides by 2. X is greater than 4. That's written as an inequality. I want to graph it. So at 4, I'll have an open circle, and I want the ones greater than 4, so I'll shade to the right. Then I want to write it in interval notation, which would be 4 to infinity. So any number between 4 and infinity makes this true. For example, if we plugged in 5, 2 times 5 is 10, 10 minus 7 is 3, and 3 is greater than 1. That's how that works. The next one we have negative 5x plus 3 is less than or equal to 6 minus 2x. Like I said before, I like to keep my x's positive, so I'll add 5x to both sides. So 3 is less than or equal to 6 plus 3x. I'll subtract 6 from both sides, and we will get negative 3 is less than or equal to 3x. To get the x alone, I need to divide by 3, and I get negative 1 is less than or equal to x. Now, it's not typical to have the x on the right-hand side. We like to have x on the left-hand side. So what I'm going to do is I'm going to flip this inequality so that x is on the left-hand side. But we have to recognize that this statement is saying negative 1 is less than or equal to x, meaning negative 1 is smaller than x. X is bigger than or equal to negative 1. So when I move the x to the left-hand side, it's going to look like x is greater than or equal to negative 1. These mean the same thing. They're both saying that x is greater than or equal to negative 1. On the number line, we will have a closed circle at negative 1, and we want the ones greater than or equal to, so we will shade to the right. An interval notation, that will be negative 1 with a square bracket to infinity. Before we move on, I want to approach this problem in a different way to show what it's like dealing with negatives. So we had negative 5x plus 3 is less than or equal to 6 minus 2x. There's nothing wrong with dealing with negative x's. I just prefer it, or I prefer to leave my x's positive. However, in this case, it might actually be better to deal with x's being negative. That way our x's are always on the left side. If I add 2x to both sides instead of adding 5x to both sides, then I'll have negative 3x plus 3 is less than or equal to 6. I subtract 3 from both sides. We get negative 3x is less than or equal to positive 3. and then dividing both sides by a -3, we get x is, we're dividing by a negative, that's that special case. If we multiply or divide by a negative, we have to flip the inequality sign. It was less than or equal to, now it's greater than or equal to. 3 divided by -3 is -1. So we're getting x is greater than or equal to -1, which is what we got before. Now we're going to work on some that are a little bit more complex. We have 30 minus 6x is less than -3 times 5 plus 7x. I'll start by distributing. 30 minus 6x is less than. Now I'm multiplying by -3. However, I'm not multiplying both sides by -3. I'm just distributing. I don't flip the sign unless I multiply or divide both sides of the equation by a negative number. Since I'm distributing, the sign stays the same. -3 times 5 is a -15. -3 times 7x is a -21x. I'll add 21x to both sides. So we will have 30 plus 15x is less than a -15. Subtract 30 from both sides. 15x is less than -45. And then dividing by 15, we get x is less than -3. On a number line, we have an open circle at -3, and the ones that are less will be to the left. In interval notation, this will be -infinity to -3. Next up, we have 6 times x minus 4 plus 7 is less than or equal to -5. Again, I'm going to start by distributing. So I'll have 6x minus 24 plus 7 is less than or equal to -5. I'm going to combine my like terms. So 6x minus 17 is less than or equal to -5. If I add 17 to both sides, we get 6x is less than or equal to 12. And then dividing both sides by 6, x is less than or equal to 2. On a number line, that puts a closed circle at 2, shading to the left for the less than or equal to. In interval notation, this would be -infinity to +2. Notice there's a square bracket on the 2 because it is included. Next up, we have compound inequalities. That's when we have more than one inequality to solve at a time. Compound inequalities can be solved one of two ways. You can either separate both sides of the inequality or by solving them at the same time. And I'm going to show it both ways so that you can see it and decide which you prefer. So first up, I will separate them. So what this is saying is -1 is less than 3x plus 7, and 3x plus 7 is less than or equal to 22. I'm going to solve each of these inequalities. So to get to x alone, I'll subtract 7. So -8 is less than 3x. This is a positive one. I knew something looked wrong. Sorry, that's a positive one. 1 minus 7 is a -6. That makes a lot more sense. -6 is less than 3x. And dividing by 3 on both sides, we get -2 is less than x. Now I normally would flip this so that x is on the left, but I'm going to hold on that. You'll see why in just a second. Over here we have 3x plus 7 is less than or equal to 22. If I subtract 7 from both sides, we'll have 3x is less than or equal to 15. So if I divide both sides by 3, we get x is less than or equal to 5. There's an and between here. So we need -2 to be less than x, and we need x to be less than or equal to 5. If I put these in order from smallest to largest, that's going to be -2, then x, then 5. We know -2 is less than x. We know x is less than or equal to 5. Another way we can look at this is similar to how we did back in the sets section. And that's by looking at the graph. If we look at -2 is less than x, meaning x is greater than -2, we would be looking at the open circle to the right. For x is less than or equal to 5, we'd be looking at a closed circle and to the left. If we want to be in both, we want to be between -2 and +5. So the graph for these put together is just going to be open circle at -2, closed circle at 5, and we want the ones in between. We would write this in interval notation as -2 to 5 with a square bracket. This tends to be the more logical way because students can really wrap their minds around it. The faster way is to solve everything at the same time. The way we do that is by solving like we would any other equation or inequality. However, there is one major change. Anytime we do something to quote-unquote both sides, we're just going to have to do it to all the sides. So if I'm trying to solve for x in this, I want to start by subtracting 7. But if I subtract 7 from the middle, I also have to do it on the left, and I have to do it on the right. 1 minus 7 is a -6. We have a less than sign, 3x, less than or equal to sign, 15. To solve for x, we divide by 3, but if I do it in the middle, I have to do it on the left and on the right. So -2 is less than x is less than or equal to 5. So much faster than the other way. The reason this works, and you may not have noticed last time, but we performed the same operations in the same order. We subtracted 7, then we divided by 3. If we're going to do the same operations, we might as well do them all at the same time. Again, our graph for this is -2, +5, open circle on -2, closed circle on +5. We want the ones in between. And then an interval notation, -2 to +5. This other one's a little bit trickier. We have -1 is less than or equal to -2x plus 3 is less than 15. I'm going to go ahead and solve it the same way I did this one, solving all 3 sides at the same time, because it's a little bit quicker. So I need to subtract 3 from all of the sides. We get -2 is less than or equal to -2x is less than 12. To get the x alone, we need to divide by -2 on all our sides. -2 divided by -2 is 1. -2x divided by -2 is just x. 12 divided by -2 is a -6. However, because I just divided by a negative, I have to flip my inequality signs. A less than or equal to is now a greater than or equal to. A less than is now a greater than. But we don't like working in this order. We like to work from smallest to largest. So -6 is the smallest, then x, then 1. And if we're working backwards, -6 is smaller than x. X is bigger than -6. So I need to make sure that I put my signs the right way. X is smaller than or equal to 1, or 1 is greater than or equal to x. So this is going to be -6 is less than x is less than or equal to 1. On a graph, we'll have a -6 and a +1. an open circle at -6, a closed circle on 1, and we want the ones in between. So in interval notation, we have -6 to +1. We have two application problems we're going to look at with inequalities. First up, a local salesman receives a base salary of $1,500 a month. He also receives a commission of 8% on all sales over $500. His goal is to have a monthly income of at least $2,500. Write an inequality you can use to solve for how much the salesman will have to sell each month to reach his goal. And then use your inequality from part A to find the minimum amount the salesman would have to sell each month to reach his goal. All right, so first up, he gets a base salary of $1,500. He gets that no matter what. But he also gets commission of 8%. So to his $1,500, he's going to get 8% of, that's when we multiply, all of his sales over $500. So the first $500 doesn't count towards this commission, but everything over $500 does. So we're going to take however much he sells. We don't know how much that is, so I'm going to call it X. X will be his monthly sales. So we want to take his monthly sales and subtract away that first $500 because he doesn't get commission on that. He only gets commission on what's above $500. So the $1,500 plus 8% times what he sells minus 500, he wants to make at least $2,500. So this amount, the amount he earns, we want it to be greater than or equal to the $2,500, which is his goal. So now we can solve this inequality to figure out how much he needs to sell. We'll have 1,500 plus 0.08x, and then 0.08 times a -500 is -40. That's greater than or equal to our 2,500. If I combine my like terms, I'll have 1,460 plus 0.08x is greater than or equal to 2,500. If I subtract 1,460 from both sides, we'll have 0.08x is greater than or equal to 1,040. And if we divide by 0.08 on both sides, we get x is greater than or equal to 13,000. So going back to the problem, we were asked to find the minimum amount he needs to sell to reach his goal. He needs to sell more or equal to $13,000. So the least he could sell and make his goal is the $13,000. All right, last one. Harry has received scores of 72 and 78 on his first two 100-point tests. What score must he get on his third 100-point test to have an average of 80 or greater? So we have to remember that to find an average, we add the things up and divide by how many there are. We're trying to figure out what score he needs on the third test. I'll call it X. So X is the score on the third test. So to find the average of his three tests, we need to take the 72 plus the 78 plus the X, because those are his three scores, divide it by 3, and we want that average to be greater than or equal to 80. I'm going to go ahead and add together my 72 and my 78. x is being added to 150, then divided by 3. So if I undo these in reverse order, I need to multiply by 3 first. So multiplying by 3 on the left and multiplying by 3 on the right, that will undo the division on the left. So we'll have 150 plus x is greater than or equal to 80 times 3 is 40. And then if we subtract 150 from both sides, we get x is greater than or equal to 90. So what score must he get on his third 100-point test to have an average of 80 or greater? He needs to score 90 or higher. Now, if we think about this in terms of the context of the problem, he has a 72 and a 78. He's trying to get up to an average of 80. So he is going to have to really score high if he wants to bump up that average. So having 90 seems to make sense.